Hi guys, welcome back to my channel. So before we start with our new concept in mathematics for today, so please don't forget to subscribe, Teacher Dong, hit the subscribe button and the notification bell for more videos and so that you will be informed so whenever there's a new video. Okay, thank you so much. So let's now have Unit 6 Triangle Similarity. So triangle similarity. In the previous lesson, we're able to talk about congruent triangles or triangle congruence. And so in this case, we're going to actually see the difference between similar triangles and congruent triangles. Alright? Now, so let's start first with our first lesson, similar triangles. So this is now the introduction on how we can actually know when when do triangles are similar or not. All right, let's proceed. But before we proceed with our introduction about triangle similarity, you please take note that we're going to use proportion in solving for the unknown segment as we go through. That's why the first thing that we're going to do now is to have our first activity about review on ratio and proportion. So remember, when we are talking about ratio, it's the comparison of two quantities, while proportion, it's actually the equality of ratios. Alright? So, find the value of the variable in each of the following. Right? So, we're going to recall now on how you actually solve for the unknown variable in a specific proportion. So, for number 1, we have b over 10 equals 6 over 5. Right? So, the first thing is we're going to use the fundamental principle of proportion, or simply the cross multiplication. Right? So, cross multiplication. So, we will multiply b and 5. b times 5 is 5b equals 10 times 6 is 60. Now, we're going to apply division property of equality, wherein we will be dividing both sides by 5. So, 5 divided by 5 is 1. So, what will we're going to have b. And then 60 divided by 5 is 12. So, therefore, the value of the variable b is 12. Alright, so we just need to use the fundamental principle of proportion, or simply cross multiply the ratios, or cross multiply the means and the extremes. Now, let's have number 2. H minus 1 plus H plus 2 equals 3/4. Right, so let's cross multiply. First thing is we have H minus 1 times 4. It is now 4 times H minus 1 equals 3 times H plus 2. Now, we're going to apply distributive property of multiplication, wherein we're going to distribute the monomials outside the parenthesis to the binomial, okay, to the terms inside the parenthesis. So 4 times H is 4H. Then 4 times negative 1 is negative 4 equals 3 times negative 3 times H is 3H, and then 3 times 2 is 6. Now, we are going to combine similar terms with the use of addition property of equality. So, for H, remove 3H here by getting its opposite, which is negative 3H, equals 6 plus, or rather, plus the opposite of negative 4, which is positive 4. Next, 4H minus 3H is H, and then 6 plus 4 is 10. So, the value of H is 10. Next, let's have 8 over j equals j over 2. We are going to cross multiply. J times j is j square. Then 8 times 2 is 16. Please recall the way of how you're going to extract the roots of the following. So in this case, we have we're going to extract the square root. So if we're going to extract this one, we have to extract also the other one. Alright, so we have to apply that in a specific equation. Square root of j square is just simply j equals square root of 16, which will become positive negative 4. So this will be now your answer. Now let's have number 4. So for number 4, we have n plus 4 over 14 equals n minus 2 over 2. Cross multiply. So n plus 4, rather 14 times n minus 2 equals 2 times n plus 4. Distribute, or apply the distributive property of multiplication. 14 times n is 14n. 14 times negative 2 is negative 28 equals 2 times n is 2n, and then 2 times 4 is 8. Then combine the similar terms, 14n minus 2n equals 8 plus 28. 14n minus 2n is 12n, and 8 plus 28 is 36. Divide both sides by 12. The value of n now will be equals to 3 because 36 divided by 12 is 3. So this will now your answer. That's it, no? When you are actually simplifying proportion, please make sure to use the cross multiplication process, or what we call the fundamental principle of proportion. And then afterwards, you have to apply some algebraic techniques for you to be able to solve for the unknown value. So that's it. Now, I think we can proceed to our main lesson, Introduction to Triangle Similarity, or Similarity of Triangles. So let's talk about shapes and sizes. The question is, which pair of objects has the same shape, the same size, or neither? So let's proceed first to the first row. In the first row, as you can see, we have the same shapes and also the sizes. Okay, so as you can see, 500 ml for the milk, 500 ml for the other milk. Okay, so we can now say that the pairs of objects are do have the same shapes and sizes. Alright, so therefore we can say that they are congruent and similar pairs. For us to say that that specific objects are similar and congruent, we have to make sure that their shapes and sizes are similar and congruent as well. Now let's proceed to the second one. Similar pairs but not congruent. So as you can see, how did we say that the following objects are similar pairs? It's because they have the same shapes but not the sizes. Alright, so we can say they are just simply similar but not congruent. So as you can see, we have the bottle of perfume. The first one is 200 ml, the other one is 500 ml, and so on and so forth. So you can actually compare the size. They are not similar. But when it comes to the shapes, okay, the pairs of objects are actually similar. Alright? So let's have the third row. For the third row, as you can see, they are neither congruent nor similar, or they don't have the same shapes and sizes. So therefore, we can say that they are neither congruent or similar. Now, in the following examples, we can actually differentiate the difference between similar and congruent. So when we say similar, we are only looking at the shape, not the size. Okay, so if the shapes are similar, or yes, they are the same, so we can say that they are similar. But for congruent, there are two factors to consider. Their shapes must be similar, or yes, their shapes must be the same, and their sizes must be congruent for us to say that they are congruent. So that's it. Now, similarity versus congruence. Similar figures have the same shape. They may not have the same size. We are using the word may. It means there's possibility that they are going to have the same size. We also call them similar. Now, the symbol for similar is this. Well, the symbol for congruent is this. So, congruent figures have the same shape and the same size. So, that's the thing that you're going to take note. Alright? Now, take note of this. Congruent figures are also similar figures. But similar figures, not all similar figures are congruent figures. What can we imply here? So we can say that congruent figures are also what we call similar figures, but not all similar figures are congruent because we have to satisfy the two conditions of having the same shape and size. Alright? Now, let's have the similar triangles. So, two triangles are similar even only if their corresponding angles are congruent and the lengths of their corresponding sides are proportional. So, for us to say that two triangles are congruent, you have to take note that their corresponding angles must be congruent, and the lengths of their corresponding side need not to be congruent, rather, so they need to become proportional for us to say that they are actually similar. Now, the simplest form of the ratio of the lengths of two corresponding sides of similar triangles is what we call similarity ratio. So, we don't have any problem with the corresponding angles because they must be congruent. But for the sides or segments or corresponding segments, they must have a similarity ratio. Okay, so this similarity ratio will actually satisfy that two triangles are really similar. Now, the symbol for similar, when you read it, is similar to. So let's say we have triangle ABC and triangle DEF. So we are saying that triangle ABC is similar to triangle DEF. Alright? Okay, so that's how you're going to read it. Okay, example 1. Name the triangles. The following triangles are similar. So that's the given. So when do we say that triangles are similar? Take note of this class. So as you can see, we have triangle FAR and triangle KIN. So according to the condition, they must have congruent corresponding angles. So it means the corresponding angle to angle K is angle F. If angle A is 53 degrees, angle F must be 53 degrees as well. Alright? Now, the corresponding to angle R is angle N. So if angle R measures 37 degrees, so we have to have also a measurement of 37 degrees for angle N. And then as you can see, there is a right angle symbol here. Therefore, their measurement is equivalent or equal to 90 degrees. Alright? Now, let's answer the following questions. Name the similarity correspondence. So, in naming similarity correspondence, we're just going to say that triangle KIN is similar to triangle FAR, or the other way around. So, triangle FAR is similar to triangle KIN. There's no problem with that. Now, letter B. Name all pairs of congruent corresponding angles. So this is very simple. Angle F is congruent to angle K. Angle R is congruent to angle N. And lastly, angle A is congruent to angle I. Alright? Those are the pairs of corresponding or congruent corresponding angles. Alright? Now, letter C, write the proportions using pairs of corresponding sides. So, you have to take note, we are talking about corresponding sides. So, FA corresponds to KI, FR corresponds to KN, and AR corresponds to IN. So, this will serve as your proportion. FA over the corresponding side, KI, equals AR over IN, or segment IN, equals FR over KN. So this is now the proportion of the corresponding sides. You have to take note that all the numerators are coming from the smaller triangle, while the other one on the denominator are coming from the blue triangle or the bigger triangle. Okay, take note of that. Find the similarity ratio. So you can solve for the similarity ratio with the use of the measurements of two corresponding sides. In this case, we are going to use FA and KI because they are the ones with measurements. Okay, so FA over KI. So FA measures 3 while KI measures 6. 3 over 6, the simplified form 3 over 6 is 1/2. So 1/2 now is your similarity ratio. So 1/2 must be true on all the pairs of corresponding sides for us to say that the two triangles are similar triangles. Okay? Now letter E, find segment IN. So we're talking about this. You can use proportion in solving for segment IN. So what's the proportion that we're going to use? So we can use FA over KI because they both have measurements, and AR over IN because one of them has measurement, and then we are only looking for IN. Okay, so we're going to use FA over KI equals AR over IN. Then the next thing is substitute the values. FA is 3, KI is 6, equals AR is 4, and then IN is unknown. That's the one that we're going to solve. That's it. We can now cross multiply. 3 times segment IN is just simply 3 IN equals 4 times 6, which is 24. Then divide both sides by 3. Segment IN is equal now to 8. So the measurement of IN is 8. So if we're going to check if we have the same similarity ratio, 4 over 8, so the simplified form of 4 over 8 is what? It's also 1/2. Very good. Okay, so find the measurement of angle N and angle F now. Alright? So the measurement of angle N is equal to the measurement of angle R. So therefore, the measurement is 37 degrees. Next thing, the measurement of angle F is equal to the measurement of angle K, which is 53 degrees. Alright, those are the two measurements that we're looking for. Okay, next. Dilation and similarity ratio. The scale factor, by the way, before we proceed to the scale factor is the same as similarity ratio. Dilation is a matter of making the object larger or smaller. Okay? We are actually getting the reduced form and the enlarged form of the object. That's what we mean when we say dilation. So what are we going to use in actually getting the smaller version of the object and the bigger version of the object? So we are using scale factor or similarity ratio. So the scale factor is the amount of enlargement or reduction needed to get a similar figure from the other. This is the ratio of the dimension of an object in its dilated image to its actual size. Alright, so guys, so let's say this is the actual size of the 10 cents coin. Alright, so if we're going to reduce the size with a scale factor of 1/2, okay, so this will be the image. If we're going to reduce it in the scale factor of 1/4, this is now the image. Notice that when the scale factor is less than 1, take note, less than 1, the similar figure is a reduction. Take note. And then, when the scale factor is greater than 1, the similar figure is an enlargement. So just like what you are seeing from the actual size, if we're going to make it bigger with a scale factor of 3/2 or 1 and 1/2, this is the image. If you're going to double it with a scale factor of 2, this will now be the version of the actual size of the object. Okay, take note. So dilation means it's a matter of reducing or enlarging the actual size of the original object. Okay, with the use of the similarity ratio or the scale factor. Example for that. Example 2. Triangle XYZ needs to be reduced by a scale factor of 1/4. How long is the shortest side of a reduced image? So we have the word reduce. So it means we're going to make it smaller. So, and then the scale factor that we're going to use is 1/4. The original size of the shortest side of the original one is 8 centimeters. Now we're looking for this one. So X now will be get the original size, which is 8 centimeters, and then multiply to the given scale factor, which is 4. Alright? So 8 times 1/4 is just simply 2 centimeters. The reduced size is now 2 centimeters. As simple as that. You have to take note of the word reduce and enlarge and the scale factor for you to be able to solve for the dilated size of the image. Alright? Let's proceed. Theorem 61. The basic proportionality theorem. If a line parallel to one side of a triangle intersects the two sides in distinct points, then it cuts up segments which are proportional to these sides. So let's label them for you to be able to easily understand it. A, B, C, D, E. So it says there in that theorem that if we have a line which is parallel to one of the sides of the triangle, okay, so there are proportional sides that are going to be formed. Let's start with this. So we can form the ratio segment AE over segment ED equals to the corresponding segments segment AB over segment BC. That's the first proportion. Next, take note of this, guys. Alright, so this one is the theorem. Now, take note that there are two triangles here. So we have the smaller and the bigger one if we're going to actually separate them. Because here, the smaller triangle is just coinciding the larger or the bigger triangle. Alright, so we can now have corresponding sides. So segment AE over the side of the bigger triangle, segment AD, equals the smaller triangle AB over, okay, the segment of the bigger triangle AC. That's the other proportion. Okay, next we can use the following. This one and this side, this one and this side. So it's AE over EB equals the bigger one, AD over DC. Next here, AB over AE equals AC over DC. Last, we can also use the 2 as the ratio. So AE over AB equals the bigger one, AD over AC. So these are the possible proportions that you can actually use in a specific example for you to be able to solve for the unknown value of the segment that is unknown. Alright, so take note. Example 3. In triangle EGT, segment RA is parallel to segment GT. EG is equal to 12. You have to take note to label, no? If there is no label, you have to label the measurement. So EG here measures 12, while segment ER measures 4, segment RA measures 6, then segment ET measures 24. The question is, we have to solve for the measurement of segment EA. Alright, so first is let's solve for EA, but first of all we have to form our proportion. So EA is here, so therefore we can use the smaller segment to the bigger segment as the proportion. It is now ER over EG equals EA over ET. Alright, that's the proportion that we're going to use now. Then substitute the values. ER measures 4 over EG measures 12. EA is unknown over ET, which is 24. Cross multiply them so that you're able to get the answer or the value of EA. So after cross multiplying, so 12 times EA is just simply 12 EA. Then 4 times 24 is equal to 96. Then divide both sides by 12. Alright, so EA now will be equal to 96 divided by 12 is 8 units. So that is now the measurement of segment EA. Next, let's have GT. GT is this one, the base. So we can use the one that we have formed a while back. Segment ER over segment RA equals the bigger EG or segment EG over the missing one, GT. Substitute the values. ER measures 4, RA measures 6, EG measures 12, and then we are looking for segment GT. Then cross multiply. Alright? So 4 times GT is 4 GT equals 6 times 12 is 72. Then divide both sides by 4. Segment GT now measures 18 units. So this will be now the measurement of segment GT. So if you do have some questions and clarification, you can directly message me or you can comment down your questions, all right, or clarifications. Now let's proceed to the next, second to the last example. In triangle DEF, segment GH is parallel to segment DF. Segment EH is 12, HF is 18, and segment GD is 6. We have to find for the measurement of EG. So as you can see, the measurements are already labeled, and then we are looking for EG, and in the symbol it is X. Right? So we can now form the proportion EG over GD equals EH over HF. So for us to be able to solve for EG. Okay? So EG over GD equals EH over HF. Then substitute the values. EG is X over GD, which is 6, EH, which is 12, HF, which is 18. Cross multiply them. X times 18 is just 18x, and then 12 times 6 is equal to 72. Then divide both sides by 18. X now, which is also the measurement of segment EG, is equal to 4. So that's the measurement of segment AD. Alright, next. Example 5. In triangle ABC with segment DE parallel to segment BC, AB is equal to 12, AD is equal to 4, and EC is equal to 10. Find AE. So we're looking for AE. So we're going to now, we are going to form our proportion AD over AB and AE over AC. AE over AC. So we're able to have our proportion. Next, we're going to substitute the values. Right, so AD measures 4, AB measures 12, AE is unknown. Then for you to be able to get AC, you have to add AE plus 10. Then cross multiply. So 12 AE equals 4 times segment AE plus 10. Substitute. 12 AE equals 4 times AE or 4 AE plus 4 times 10, 40. So substitute, you have to combine similar terms. 12 AE, the opposite of 4 AE, applying addition property of equality is negative 4 AE equals 40. 12 AE minus 4 AE is equal to 8 AE equals 40. Then divide both sides by 8. So therefore 40 divided by 8, segment AE measures 5. So this will serve as your final answer. That's it. Okay, so for my students, you please accomplish this one on your activity sheets, and then we will be checking it next meeting. Alright, so thank you so much for listening for this specific session about similar triangles. I do hope that you have learned a lot. So please don't forget to hit the subscribe button and the notification button for more videos. Again, this is Teacher Dong, and have a nice day to everyone.